Our research is about creating and adapting game-playing agents. In particular, we are researching failure-driven adaptation. We've designed a tool called GAIA to create, adapt, and run game-playing agents, modeled in the TMKL2 language. We will show two TMKL2 agents playing a game in the FreeSim environment. One agent will succeed and one will fail. We will show the failed agent adapting its model and then winning the next time it plays. First, we will show each agent's model in our GAIA software. We will briefly discuss the TMKL2 syntax and discuss Alice's and Barbara's strategy given by their models. We will then have Alice and Barbara play a game against each other. Displayed is GAIA's user interface. A TMKL2 model specifies an agent in terms of its goals and how it achieves them with a mechanism. Displayed on the canvas is a model of an agent named Alice. The green box represents the agent's top-level goal. Her top-level goal is named Alice Win. Given and makes are logical expressions. Given specifies what should be true before a goal is attempted to be achieved. Makes specifies what is true after a goal has been achieved. The makes condition Alice.gold_win is true if Alice has collected 185 or more gold. The blue box displays a state machine which specifies how Alice achieves her top-level goal. Every state except the success state has its own goal. When a state is visited, its goals mechanism is executed. A top-level goal is decomposed by sub-goals. This hierarchical decomposition creates a tree structure, where the bottom-level goals have primitive mechanisms called operations. Each transition has a guard given by a logical expression. This particular guard tests if Alice has 4 warriors in her cities, then attackers on the map she's playing on. Displayed is a view of the agent's knowledge. All logical expressions are over the agent's knowledge. The agent's knowledge ontology is defined by concepts and relations. Instances of both concepts and relations make up the agent's knowledge. At a high level, Alice's top-level goal is to collect 185 pieces of gold. To do this, she first creates a defense for her city. This initial defense checks how many initial attackers there are on the map, and then guards her city with 1 more warriors than there are attackers on the map. She then begins producing gold in her city. Her city is named City 104. Once she has collected 185 or more pieces of gold, she has succeeded and ends the game. Meet Barbara. Barbara is Alice's enemy. Barbara's sole mission is to destroy Alice, and if Barbara can destroy Alice before she collects 185 more gold, then Barbara is victorious. Barbara's strategy is very simple. She produces a warrior and attacks Alice's city. She then repeats this process until Alice is dead. However, if Alice gains 185 gold before Barbara can kill her, then Barbara fails, and Alice succeeds. Otherwise, Barbara succeeds, and Alice fails. Now let's run Alice versus Barbara, and see who succeeds, and see who fails. We now select the models that we want to play against each other. Here we select Alice versus Barbara. A TMKL2 runtime is now preparing to run Alice and Barbara. We will now connect as an observer to watch Alice play. We will now tell both Alice and Barbara to start playing the game. The window highlighted currently monitors interesting values occurring in Alice's knowledge. The first value is the number of enemy attacking units on the map. The second number indicates how many warriors are in Alice's city. The third value is what the city will produce when Alice has ended her turn. The fourth value indicates how much gold Alice currently has. The fifth value indicates if Alice's city, City 104, has been captured or not. The sixth value indicates if Alice is alive or is dead. The seventh value indicates if Alice has finally ended her turn or not. Barbara and Alice's knowledge is initialized with the initial state of the environment. As you can see in the map overview, Barbara has begun her attack. Barbara's warriors approach City 104 to demolish it. Notice the combat has begun. Alice won the first two battles. The third battle. The fourth battle, and she has lost the sixth battle, and now she has failed. She was only able to collect 141 gold, and she lasted to 2500 BC. Now we are going to try to adapt Alice's model. Let's look at Alice's knowledge state at the end of the game. You can see all the tiles populated, the enemy units, players. You can see Barbara won with a brutal win, and that the game is over. We now request that RIM try to localize states that possibly did not execute, but if they had, then the agent would not have failed. We call these states problem states. The states highlighted in red are the found problem states. For each problem state, the adaptation algorithm will try to add a new state, so that after this new state is executed, the problem state will now also execute. We call these new states patch states. We now ask our reasoner RIM to find patch states for the problem states highlighted. Our reasoner was able to find a patch state for one of the problem states found. The patch state has a goal to build wars in City 104 until they outnumber all enemy attacking units. The problem state, State 16's goal, failed previously because City 104 was captured. The patch state will help prevent State 16's goal from failing in future runs because the patch state has a goal to build warriors, which will help defend the city from being captured. Let's now run Adapted Alice versus Barbara and see who succeeds and who fails. A Team Kill 2 runtime will now begin to interpret both Adapted Alice and Barbara. We connect as an observer to observe Adapted Alice. We now tell Adapted Alice and Barbara to start playing. Keep an eye on the values highlighted. When Barbara has more warriors than Alice has warriors in her city, Alice will stop producing coinage and begin to produce warriors to protect herself from Barbara. When Alice has more warriors in her city than Barbara has warriors attacking, she will begin to start collecting coinage once more. Alice has succeeded. Her adaptation to increase her defense against Barbara's warriors was successful.